Hello everyone, my name is Nick and I'm going to try to solve a Leetcode problem. Hopefully someday I'll solve them all on camera, but what I'm doing today is solving the first Leetcode problem, and I'm going to try to do it as instructionally as possible and at least kind of expose my thought process, almost as if I were getting this question as like an interview. So let's jump in. The first one is called toSum, and the prompt, which I'm going to start with, is given an array of integers, return indices of the two numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You may assume that each input would have exactly one solution. Okay, that's helpful. So for example, if you're given 2, 7, 11, and 15, the target is 9, you would want to find 2 and 7. And then, okay, we return it as an array. Cool. So, okay, I cannot forget to speak my thoughts. And is there any parameters about the time complexity? I don't see anything. This prompt is rather short, which is awesome. So here we go. So we're getting nums and target. So my first thought is I can loop through the number array twice, like in parallel. So one loop would be the first number, and the other loop is to try to find the second number. So I would compare, I can't use the same element twice, but say I would compare 2 and 7, and that would succeed, but say it didn't, we would compare 2 and 11, 2 and 15, and if all those failed, we would move to the next number, and we'd say 7 and 2, 7 and 7, 7 and 11, 7 and 15. I think this is probably like the brute force solution, and not necessarily the fastest one. But I don't know if there's a faster solution. If I struggle too much, I'm probably just going to edit some of this time out. But I'm just going to sit here and think about it for a few seconds and then see if I can't come up with something better than the brute force solution. So instead of looping over the numbers twice, I could trying to think use a hash map. I don't think there's any way a hash map would help me. I could try to eliminate any numbers that are larger than the target, though I think that would not really help me much either. And 2n as a complexity is not that bad, but it would be nice to do it faster somehow, although I really don't think there's a better way. This might be really quick, so let's get started. Okay, let's rewrite it. I guess we'll write it with a loop and just see how that goes. So we're going to define two variables. Let's say hi and j are both going to be 0. I don't even know if there's a faster way to do this. I don't think there is. And then we need two loops. I wonder if a for loop might just be better and just scratch the whole while loop idea. But honestly, I haven't written a for loop in JavaScript in so long. I believe it goes like this. I is less than nums.length -1, ++, and then do j, exact same thing. I hope my typing isn't obnoxiously loud. So I is going to be our first pass over the array, and j is going to be the second, or the parallel pass to it. So we'll say I don't know what to name each side of the sum, but I just call it num1 and num2, but I don't really want to go down that route. So let's call them like outer and inner, maybe. Outer num is nums I, and all this variable definition isn't necessarily required, but I prefer to just write them out and not confuse myself with all kinds of operations on one line. So we want to check if the addition of these two together is equal to the target. And if it is, then we simply return I and j. And if they are not equal to the target, then we let the loops continue, which will happen automatically. So we really just need to check, and I think we do assume that there is a solution, so we're okay there. Another check we want to do is I and j are not the same. So actually, like in this loop, if I is equivalent to j, we're just gonna, I think continue is the keyword. Okay, so now we're in a safe space to compare the addition of outer num and inner num to the target, and if they're equal, return. Otherwise, continue with the loops. And this, I believe, is guaranteed to find a solution. So I think all we really have to do is check if outer num plus inner num is equivalent to target. And if so, then we return I and j. And it's going to be super embarrassing if I get this wrong the first time, but hey, I probably will. And I made a syntax error, which is not surprising considering I've never, okay, right. Oh God, what is this? I believe that we need semicolons, not commas. So let's fix that. Cool, another one. Wait, oh, right. There are two for loops. Shocking. Okay, so we succeeded on that one, which probably means that if we submit, it will just work. I feel confident. Oh my God, we failed. That's hilarious. Wait a minute. Okay. So we gave undefined. Cool. Nope, that's going to happen. These videos would not be interesting if the professional software developer did not make mistakes. So why did we output undefined? Oh, I think we're not letting our loops get all the way to the end. I did less than, but I also subtracted one. I should have done either or. I can do less than equal, or I can get rid of the subtraction. I think I'm going to get rid of the subtraction because I like that better, but it might be more clear the other way, depending on how you like it. It doesn't really matter to me. Cool, so we finished. We're faster than not very many of the submissions, and our memory usage is not much better than any others either. This means there's probably a faster way to do it than what I did, but that's what we're left with. So I did think about this a little bit more, and this can definitely be solved a lot faster than n squared. I said 2n earlier, but it's actually n squared because we have a loop inside of a loop, both going over the full length of the array. So a way to optimize this, or at least one of the more accessible solutions, is to start our inner loop at the same index as our outer loop. Because, for example, if we were using the example on the left side here, by the time the outer loop goes through comparing 2 and 7 and 11 and 15, when we start at 7 on the next outer loop, we don't need to compare it to 2 anymore because we've already made that comparison. Likewise, when we get to 11, we don't need to compare 11 with 7 and 2 anymore. So our inner loop becomes a lot shorter, and the farther our outer loop gets, the shorter the whole problem gets as a whole. So I think really the only change that we need to make is making j equivalent to I. However, we know that we're not allowed to use the same element twice, so we can set it to I plus 1. And following the same rules here, I don't know if they're going to send us like an input where it's only like a single element long. They probably won't. So I'm not going to say that j equals I plus 1 will probably just work. Likewise, I don't know if our check on line 9 is necessary anymore. There is actually a hash map solution. And I've used the hash map solution before, and it was not my first thought this time. Which happens, I think, when I'm being recorded or when I'm in an interview. Honestly, it stresses me out, and it's hard to think straight. But, so let's implement the hash map solution. I think we will do better than average, or even right now our submission is doing worse than average, to speed this up quite a bit. So we're just going to clear everything, and the hash map solution, to talk it over, starts with mapping, so iterating through the array once, and mapping each number, creating an entry in a hash map for each number value in the array, and then looping over it one more time, and checking if the correct solution or the correct the number that we need to reach the target exists in the hash map. So if we go back to the example, we would create a hash map. So it's really just going to be like 2 is true, 7 is the key, value is true, 11 is true, 15 is true. And then we'll loop over it again, and we'll see 2, and we'll say, okay, to reach the target 9, we need 7. Is 7 in the hash map? And we would immediately say yes, because we had stored it in there on the previous loop. And this solution is going to be directly complexity O of n, or 2n, or whatever, but I think usually that is just simplified down to O of n. So let's code it up and see if we can't get a better score from Leetcode. And in JavaScript, I think there is like technically a hash map, but we're just going to use an object. It might be slower, I don't know, but we're going to use an object anyway because I'm not super familiar with hash maps. They might just be called maps, whatever. So our, let's see, we're going to call it values. It's just going to be an object. And then we will map over the numbers once. So we'll do a for loop. We'll say num of nums. So our num here is just going to be the number value itself, not the index. This is a different way of writing for loops in JavaScript. And then we'll say values num equals true. So it's going to say the number exists in the array. And then we'll loop through the array one more time. We'll just call it the same variable name. I hope it's not too confusing. And then we'll say the answer that we need. I'll call it needed. Needed num is equivalent to the target minus our current number. So, for example, if we were on 2, the needed number is 9 minus 2, which is 7. And then we would look for 7 in the array. So if values needed num, and we can use this this return value plainly in the if, because we set it to true here. So if values of needed num is true, then we can simply return we don't have indexes. That's going to be a problem. So actually, we need to change this quite a bit. I forgot that we needed indexes. So we can't just set it to true. I think the better idea is to set it to the index, which means we also can't use our for loop like this. So we're just going to basically scratch this and rewrite it. So I equals 0. I don't know if it's it doesn't matter to have let or not have let, but we're going to do it. And then I is less than nums.length, I plus plus, and then say values num equals, oops, I. And then now our map maps from the number itself to the index at which you can find it in the array. And then same thing here. We'll have to go through them again. I is less than nums.length. And then, oops, we'll say our needed num is target minus, nums I, and if values of needed num is not undefined. So we have to compare to undefined here. We can't just use a truthiness value because our index might be 0, and 0 is false or falsy in JavaScript. So we can't just say if values of needed num like we did last time, because if the index was 0, it would not trigger the if statement. So now, if it's not undefined, then we know that we found the answer, and we can return, does it matter which order the indexes are in? It does not say. I wonder if it will accept either answer. Probably it wants them sorted, which means I believe whatever we're at now is the smaller one, and then whatever's in the map will be the larger one. Let's see if that works. Awesome. We have an error. Num is not defined. Cool. That makes a lot of sense, because we never got the num. Oops, and now it is defined. And let's see if it works. Cool. So the test worked, which means hopefully the full submission will work as well. Ooh, wrong answer. Oh, forgot about the double problem. So, interesting. Oh, what is happening? We'll say, oh boy, let's say, I don't know what to name this, but basically we need to check if the index of the needed num is equivalent to the, if the index of the needed num is equivalent to the index that we're at right now, then we should ignore it. In fact, we can just continue. So let's just get the index out. So const needed index is values needed num, and if needed index is equivalent to the one we're at now, we'll just continue, because we can totally skip this index because we know that there's only one right answer. We don't need to check anything else. And then we can replace this with needed index. And I believe that'll work. Values needed num. We can also replace this with needed index. We'll just clean up the code a little bit for fun. Okay, we succeeded on the test. Okay, that is a much better result. We've gotten much closer to doing Okay, that one's not as good, but that's okay. I think we're doing like what is maybe one of the best answers, at least close. I think possibly using a map, the map construct in JavaScript would maybe be faster than using a plain object. I'm not sure. I'm probably not going to test it. So there we have it. And I hope this was instructional. I'm glad we got to a much better answer than what we had before. Please let me know if you have any questions about what I did, any of the code that I wrote. Why am I using Vim? Why did I choose Leetcode? Whatever questions you have. Like I said earlier in the video, I never write for loops. And so the reason I was writing for loops is because I think they're more, what do I want to say? I think they're easier to understand, or perhaps more what a beginner is likely to have seen. And I'm trying to make these videos as accessible as possible. But the truth is, if I were writing this myself without trying to think about that, I would not write for loops. And something else I want to change about the solution is I actually do want to try the JavaScript map object out and see where that gets us. So we're going to scrap this and rewrite this how I would prefer to see it. We'll still write it in a performant way. So I'm not going to do like a bunch of fancy immutable object stuff. I want to write it more functionally, but still performant. So that's our goal. So we're just call this map for now. We're going to, no, let's call it values. So our old values object is still going to be the same, but it's going to be a map now. Actually, scratch this. Sorry, what we need to do is get our values out, but it's going to come from a reduction of the numbers array. So we're going to reduce or change the numbers array into a map object. And the way that we're going to do that is using the reduce function. By the way, if this is like way over your head, feel free to skip it. Don't watch it. But I wanted to include it because this is what I would do, and I want to introduce anyone to this way of solving problems, and maybe you'll like it better too. I don't know. So in reduce, the first argument is the final outcome of the reduce, so what you're going to reduce it to. So we're trying to reduce this to a map, so we'll just call this map. And the second argument of this function is going to be the number itself. And we're defining a function here. And we're going to put this in a function body. We'll leave it empty for now because the reduce actually takes two arguments. The first one is a function. The second argument is the value that you want to start with. And that is going to be a new map. So the first iteration, or the first time this function is called, we're going to have an empty map in this value, and we're going to have the first number in this value. So for the example, that would be the number 2. So inside the function, we're going to say map.set number to the index. And we don't actually have the index here, but we can get it really easily because the third argument here, it will be the index. So we set number to the index on the map, and we can actually just return that. And so that will give us a map at the end that is pretty much equivalent to what we had last time, which is a map of number values to the index at which you can find them. And to go through this a little bit more, so the first time we get into this function, we had map being a brand new map and the number being the value 2. So we set in that map the key 2 will have the value of 0 because it's at the 0th index. And then the second time this function is called, our map is going to be the map that we set that first value to. So it'll be a map with a single key of 2 and a single value of 0. And then we're going to alter this map again and we're going to set the number 7 as the key to the value of 1, which is the index of the second time this function is called. And we can return the result of calling .set because I looked it up. If you call .set, it returns the map value itself. So we could also, if we didn't know that, we would get rid of this return and then we'd return map. So this is exactly equivalent, but the other way is a little bit shorter. And also knowing that this function body is only a single line, we don't need the body definition or these was this function block. We can simply do something like this, much simpler, and we have a spare space there. So now we don't need the function body anymore, or rather, this is still the function body, but since it's a single line, we don't need to define it in a block or in a set of blocks. Rather, surround it in curly braces. So this does the exact same thing. It's a little bit more terse. And so we still have our values map. And now we're going to use our values map to determine, to find the correct pair of indices that we need to reach the target. And I'm like trying to remember what I did last time. So we have to loop through the number array again and find or use the map to find the answer. And I think we're going to use a reduce again. Last time we returned from inside of a for loop, so we like short circuited the for loop and just straight up returned because we knew we would find an answer. But this time we're going to actually return a value, or at least we're going to try to. So let's see, we're going to say our indices, our pair of indices, but we're just going to call them indices, is nums.reduce. And same thing here, map num and I. And we are going to define a function body. I think we're going to need it this time. And then our value is actually just going to be, because in Vim that deletes the last word, but in Chrome it closes the window. So that was fun. So I'm actually going to use null here just because I like it better than undefined. It doesn't really matter. But the reason we're going to use null is because one, it's falsy, and two, the final result is going to be we're going to like short circuit the reduce in a way, but not by returning directly from it. Maybe it will make more sense once I implement it. So in the same vein here, I wish I'd kept the old code so I could reference it, but we want to check, I think we said what needed num is equivalent to target minus our current number. And then we said if the needed num was, or if our values.get, so we have to use .get because we're using an actual map instead of an object this time. If values.get needed num is not equal to undefined, we can't just use the falsiness of it. If it's not undefined, then we return the index, which, so let's say needed index, I forgot to define that, values.get needed num, and whoops, needed index is not undefined, then we return I and needed index. And then last time we got burnt because we did not check the needed index is equal to the index that we're currently on. So if needed index is equal to I, then we just skip this one, which is equivalent to like returning null, which is the original value. I could also just return, but that would change to undefined. Doesn't really matter. And also, if this isn't true, this line 15, if it's not true, if I did not find the number that we need in our map, then it actually will change to undefined, because this is just going to return nothing. We could return null here, just for fun, just to be more explicit. But there's one thing we're actually missing here, is the short circuiting part, which is that if we reach this and we actually find an answer at one point, we don't want to keep going. We don't want to change our answer back to null. So at the beginning of this function body, we'll say if, I should not name that map. This is going to be like answer. So if our answer is truthy, meaning it's this array of 2 values in it, then we just return answer. So every time after we have found the answer, when this function is called, it's just going to immediately return the answer. It's not exactly a short circuit because it still iterates over all the numbers, but it doesn't do any more work in the array. And that's kind of the way that you can short circuit or reduce, but it's not as fast and it won't be as performant necessarily as just returning directly from the inside of a for loop. And we can't return directly from inside of a reduce because we are actually inside of a function here. And our return statement is going to return this function that we're inside, not necessarily the function that's defined on line 6. So now we have our set of indices being returned from this reduce, and we can just return the indices. And let's see if we got this right. Okay, we did. That just gives me a lot of confidence in just straight up submitting it. I expect this will be slower, or it might even be average. Okay, actually, pretty good solution, or pretty good speed there. We did use more memory than most. I don't know why. I wouldn't necessarily say, okay, yeah, our memory is just kind of, it's not different than before. It might be a little bit higher. I can't necessarily say why. I'm not too worried about it. I don't try to optimize for memory a lot. And to be honest, optimizing for performance is not something I have to do frequently in the job, but as part of these code solutions, I know that it's important to think about, and then that's why we focus on it. So I believe this will be my final answer because this is how I would actually want to write it. I would actually probably just skip out on returning null here. I would skip out on this null actually as well because, actually no, I can't do that because the way that reduce works is if you don't give it a default value, it will provide you with the first value in the array, which means that we would get, for example, if we used this example here, our answer the first time through would be set to the number 2, which is truthy, and then we would skip the whole thing and we would just be wrong. So we do have to put null here, or undefined, doesn't matter. This could be undefined, or it could just be return. I don't know what else I would really do to clean up this code. I think this is pretty good, to be honest. I might go about changing some of these variable names, but I think it's not too important at the moment. I think you get the gist. And yeah, there we go. Hope you liked this. Hope I didn't provide too many solutions. This video feels really long. Great.